Alright, so this is the numerical calculation. I did it using glowscript.org just because it's easier and we've had practice with it in class. So to start out, K is already defined as 100. Then L1 and L2 are both defined for the length of the spring. And so 0.4 is the stretch of the spring, which is determined later. The mass of the spring is 2.5. And then I set T equal to 0.7. And then V equals 2 times pi times L2 over T. And then it'll print the V value at first for the program. But it'll only print V once. So then the pivot point is defined at vector 0, 0, 0, so it's at the origin, and the radius is only 0.02. The ball is determined at the longer length of the spring, the stretched length, whenever the program first starts. And the radius is 0.05. I made it red and I made the trail true, that way you can keep up with where it's going. And the spring itself, I made a cylinder instead of a helix just because personally I prefer the cylinder. And its position makes it look like it's attached, or makes it to where the pivot is attached to the ball. So then over here you have ball.p equals the mass times the vector of 0v0, and v is already defined up here. So then you have the initial time is 0, and then the change in time is 0.001. So then while the time is less than 10, at a rate of 0.05, that way you, or 0.5, that way you can keep up with it and write down like the numbers that are printed out. The length is, or L itself, is the ball's position minus the pivot's position. So it'll just keep subtracting those. And then the stretch is the magnitude of L minus L1. And then the force is negative K times the stretch times the magnitude of the length. So then ball.p is updated, the ball's position is updated, and the spring axis is updated all at once. And then you have the time is also updated until it gets to 10. So, and then for every time that it does these calculations, it prints out f as both a vector and the magnitude. So then we run it. And as you can see, it still goes a little slow because 0.05, or the 0.5 rate. But you have enough time to read these answers down here. So the force is given in both the vector and magnitude.